All right, well, for the folks that are in the room and the folks that trickle back in, here is how this next section is going to work. And we've got a couple more of these both today and tomorrow. Again, this is a conference and innovation showcase where we're showing off some of the future of the mining innovations and some of the solutions that we've been working to support and develop through MICA. So what's going to happen here, we're going to put a bunch of these companies up on stage. They're going to have 10 minutes to present about their solution. And then you can find them for questions about it after lunch or during lunch. Okay, so we're going to kind of do rapid fire. We've got about, I think, 6 or 7 companies that are going to come up next over the next course of the next hour. And we're going to start with Zac Young, the Chief Operating Officer and co-founder of H2Nano, to talk a little bit about their project and how they're harnessing the sun to do brine management. So thanks, Zac. Take it away.
All right. Thanks, Kyle. Good morning, everyone. As introduced, my name is Zac. I'm presenting today on behalf of the team at H2Nano. We're a water treatment and environmental technology company with a specific focus on bringing natural energy sources and sunlight as a solution to reduce the energy and GHG intensity of water management for mining operations. So I'm going to present a little bit about some of the projects we're working on focused on that. So we've been fortunate to be supported by MICA for both the first call and the third. So the first project we worked on focused on our technology called SolarPass, which is a sunlight-activated, chemical-free method of treating contaminants in water, metals, and organics using a passive catalytic oxidation, so a reusable material that we can use to remediate that water, either treatment in place in a tailing structure or as a dedicated system. I'm going to talk a little bit more about a new technology building upon that that we're working on currently called Oasis, which is a similar approach but using these floating materials to be able to do enhanced evaporation. So for dewatering and brine management applications, both in solution mining as well as just general management of tailings waters. So our technology at its core is a advanced material, but built for scaling to the mine industry operations. So what we've done is combined nano-scale functional materials with a easy-to-use deployment method to be able to use these treatment systems in active mine operations. So those being photocatalytic materials, sunlight-activated processes for generating chemicals from the water, like solar energy production for electricity, but instead generating chemicals for treatment. And this project we're working on right now, which is focused on photothermal materials, so using sunlight energy more efficiently to be able to release water in the case where we want to concentrate those waters for reducing volumes. So Oasis is a technology that enhances evaporation pond efficiency naturally without any added energy. So we deploy the material onto the surface of the water and using a mechanism I'll describe shortly, we're able to improve the rate of evaporation from those existing ponds. So either current evaporation ponds and systems or adding this as a functionality for managing water, both in locations where you may have a positive water balance or in more arid regions where evaporation processes are more commonly used. And so we're using this to accelerate either disposal of water, especially where we want to concentrate up or at least reduce some of the total water quantity, or for brine concentration, so where membrane processes like reverse osmosis are being used in generating a waste stream that still needs to be treated and ideally on site without having to truck it away for disposal, or using more energy intensive methods to reduce that final water volume. This also improves local air quality and safety. We've used these materials. The technology I didn't mention in the introduction there was a version of the product we've been using for reducing emissions from water bodies. So where there's a source of things like hydrogen sulfide gas or odors, we can use this material to both reduce those emissions from the water as a reactive cover system, while also continuing to improve evaporation. And in comparison with conventional sprayer technologies for evaporation enhancement, this doesn't generate an aerosol that sends a bunch of salt and contaminants into the sky. Finally, with a goal of reducing land use, so especially where there's constraints on the land area that the mine is operating or trying to reduce the overall size of tailing structures or evaporation pond structures, we can use this technology to use the same footprint or less footprint to be able to do the same water management. The goal for this technology is to both reduce the cost of that water management and reduce the overall GHG and energy inputs to do that process. So how does it work? H2Nano's technologies are floating beads. We pump them out into the water within a containment structure or in a dedicated pond. They absorb sunlight. In this case, for Oasis, it's absorbing that heat energy, converting that into heating at the water surface where evaporation happens, and improving water wicking and transport to make sure that we're convecting away as much water as possible. We can also add in that photocatalytic treatment to generate treatment chemicals where the water may require it, especially where we have that concern about volatiles coming off the water or gases that we want to treat before they're emitted. Through all of this, we can deploy the material, operate over a treatment season, especially for Canadian operations, we generally be operating during the summer months, and then recover that material back off the pond through a skimming operation. So all of this is low energy, both in its actual operation as well as its deployment and collection processes. The idea here being a durable material we can deploy out on the water and take advantage of the mine scale in terms of sunlight energy that's landing on these ponds anyways to be able to do treatment. So applying this technology currently, we're working on a few different project areas. One of them, our background is especially in oil and gas. Our first project was focused on oil sands mine water treatment, so the large tailings ponds you see as part of surface mining in Alberta, treating that water using this photocatalytic process. So we're working on a similar application of Oasis and our SolarPass technologies into managing produced water as well, so where we're looking at a really highly concentrated contaminant where it may be more productive to just reduce the volume before trucking and downwell injection than doing a complete treatment for reuse. As well as in tailings water management, so volume management, as well as brine mining, where we're looking at where we can potentially enhance processes where we are concentrating up a subsurface brine to be able to generate an ore product, so especially in potash and lithium mining. As well as then in desalination and power utilities, especially where we're generating a concentrate and a more cost-effective way to do that final dewatering of the concentrated brine would be advantageous. So H2Nano's focus right now is on deploying these technologies at mine scale. So characterizing where we're at in the process is a TRL 8 to 9 level of deploying these technologies into active mine operations and validating them. As many of you know, getting things to from the prototype and first field testing scale to a fully operational stage is still, an order of magnitude or two to bring those things up. So that's the process we're currently working through at H2Nano. We've got some really exciting projects ongoing right now that are building upon our first micro project that we're looking to bring to some mine sites in the oil sands region this coming summer. And then with that as well, for this Oasis technology as part of the current MICA program, doing some first testing this summer to validate that that technology works at successively larger scales using some of the facilities we have in Alberta to test in an outdoor environment with water brought in from industry. So these facilities, these teams and capabilities that we've trained up through the MICA program are available for us to engage new partners and new potential applications. So that's one of the things that we're looking to meet more people and discuss where this technology could be impactful for mine operations for others. So as I mentioned, from a lab scale assessment, we've got a fully outfitted lab that is able to take in water samples, generate a feasibility assessment for the technology, bring that to a field pilot demonstration, which is where these MICA programs are focused on being able to show the technology works in an operating environment on live samples from the industry, and then bring that to a full-scale deployment where we're deploying the technology into successively larger projects. Interested to hear more from everyone here today on where our technologies could help with tailings water management, brine management, and doing so in a way that reduces the overall cost and energy requirements for being able to treat that water and either meet discharge goals or reduce the amount of release to the environment and management of that water that may be necessary in operations across North America. So thanks very much, and look forward to talking with you more later.